Next, exercise 5.5 is about differentiation but using log function, so logarithmic differentiation. Now here if I take for example y equals to, let's write x square, you know what is derivative. Dy by dx is 2x, that we know. Next, if I take y equals to 2 raised to x, variable, constant. Now constant, variable. Then derivative, you know, being exponential function 2 raised to x into log 2 to the base e, that we know. If I have y equals to 2 raised to 2, this is just a constant, so dy by dx will be 0. Now these three functions, variable raised to constant, constant raised to variable, constant raised to constant, we know, and how to differentiate such functions. Now fourth type of the function, that is variable raised to variable form, function raised to function, we are going to discuss in this exercise. That is, we have variable in the base as well as in the power. Which type of the function? Such functions. You look at this, x raised to sine x, x raised to x, y raised to x, sine x raised to cos x. These are all called variable raised to variable form. Now you cannot differentiate these as x into x raised to sine x minus 1. This cannot be done, remember. If you do like this, this is wrong. Here, these functions, these are the functions of the type variable raised to variable. So, derivative of all such functions will answer by logarithmic function, remember. We'll answer such functions, variable raised to variable, using log function. For example, if I start with this, for example, I'll take this, y equals to x raised to x. You see, this is variable raised to variable form. If I write derivative of this one as x into x raised to x minus 1, this is wrong, remember. This is not correct. You cannot take this power in the product and one less. That is possible only when you have variable raised to constant, remember. That's possible only when you have variable raised to constant. Here it cannot be done. So what we do? We use logarithmic function. So I'll apply log on both the sides. So this is equals to log y equals to log of x raised to x. Now you know that this power of this you can take into the product. We did as one of the property, if you remember. So log y equals to x into log x. Which property? This one. Log of x raised to n, if you remember, equals to n into log x. We did as one of the important property of the log function that I've used here. This power will be in the product. Now differentiation. This is like implicit function. So differentiating with respect to x on both the sides. So what is derivative of log y? Chain rule. Imagine there is x. So 1 upon x means 1 upon y into dy by dx. 1 upon y into dy by dx equals to, now product rule on the right hand side. X as it is, what's the derivative of log x? 1 upon x. Plus your log x as it is, what's the derivative of x? 1. So therefore finally dy by dx equals to, y will go this side, y into 1 plus log x. But what is y? Y is in turn x raised to x. So your final derivative is x raised to x into 1 plus log x. This is derivative of which function? X raised to x. Here you see y is x raised to x. So what's the derivative of y? Derivative of y means x raised to x. What's the derivative of x raised to x? X raised to x into 1 plus log x. So this way we have final derivative here. And we try to solve function of the form variable raised to variable using this concept. Question number 2, second question, first question only, first question, exercise 5.5. This exercise is based on logarithmic differentiation. So we use everywhere log function. So let me take here y equals to cos x into cosine 2x into cos 3x. Remember, this is not of the form variable raised to variable. So without log even it can be done, but I am using log here, applying log on both the sides. Applying log. So log y equals to log of, product becomes addition if I apply the log function. So log of cos x plus log of cosine 2x plus log of here cosine 3x. Which property I've used? Into becomes addition. That's a property of log function, This into becomes addition if you apply the logarithmic function. Okay. Now differentiating with respect to x. Again, I'm emphasizing this step is not must here because this is not variable raised to variable form. You can do directly by product rule, but this exercise is mainly based on logarithmic differentiation. That's why I applied the log. Now recall what is the derivative of log y? 1 upon y into dy by dx. Chain rule. I repeat. Imagine y as x. So 1 upon y into derivative of y with respect to x, dy by dx. Chain rule, remember. Equals to, now here also chain rule. What is the derivative of log x? 1 upon x. So 1 upon cosine x into derivative of cos, which is minus sine. Plus, come to this. What's the derivative of log of cos x? 1 upon cosine 2x into what is derivative of cos 2x? Again chain rule by considering this as x. So minus sine 2x into 2. Derivative of 2x, which is into 2. I hope all these things are clear to you now. Plus derivative of this. Imagine this as x. So this is 1 upon cos 3x. What's the derivative of log x? 1 upon x, 1 upon cos 3x. Into, by chain rule, derivative of cos, which is minus sine 3x into 3. Why 3? Derivative of 3x, chain rule. You have used chain rule twice, here. So therefore, here dy by dx equals to, this y will be in the product. This is minus 10x. This is minus 2 times 10 2x. Sine upon cos minus 2 minus 3 times 10 3x. If you want, you can take minus common and value of y. What's the value of y? Cos x into cosine 2x into cos 3x. And 10x plus 2 times 10 2x plus 3 times 10 3x. This is your answer. This is dy by dx, remember. This is dy by dx, final derivative. I hope now this is clear to you. What I did, I'll repeat this step. Derivative of log of cos, 1 upon cos into derivative of cos minus sine. 1 upon cos 2x into derivative of cos 2x minus sine 2x, derivative of 2x is 2. Derivative of cos of 3x, 1 upon cos 3x, derivative of cos 3x, which is minus sine 3x into derivative of 3x, which is 3. And then just simplification. So this is one. Next question. If I go to question number 2 here. There, let me write y equals to root of x minus 1 into x minus 2 upon x minus 3 into x minus 4 into x minus 5. Now this is again not of the form variable raised to variable, remember. So without logarithmic also you can do, but this exercise is mainly based on logarithmic functions. I'll apply log on both the sides. Okay, without log it can be done, but it becomes very complicated, you can see, because you have square root, you have product, you have division. So if you apply log on both the sides, it becomes little bit easier. So log y equals to log of, let me copy this expression, x minus 1 into x minus 2 upon x minus 3 into x minus 4 into x minus 5, root means raised to 1 by 2. Now in logarithmic questions, before you do derivative, you should use the properties of the log function. So I'll use the property of the log function on the RHS. Differentiation is not important right now, log y as it is. First, this power will be in the product, so 1 by 2 in product. This division becomes subtraction and multiplication become addition. So I'm writing here log of x minus 1 into becomes addition, log of x minus 2. Now this division, so this will be in the subtraction, minus log of x minus 3 minus log of x minus 4 minus log of x minus 5. I repeat this step. What I did here, I've used the properties of log. Which property? This power will be in the product, that you know, as I explained. This into become addition, and because of the division you have here subtraction, remember. This is what the simplified form. Now we differentiate it. So differentiating with respect to x on both the sides. So the next step will be now what is derivative of log y? 1 upon y into dy by dx. So here 1 upon y into dy by dx. You know, by chain rule, now we did number of times, equals to 1 by 2 being constant as it is. What is derivative of log of x minus 1? You imagine x minus 1 as x. So 1 upon x minus 1 into, by chain rule, derivative of x minus 1, which is just 1, plus 1 upon x minus 2 into, by chain rule, derivative of x minus 2, which is again 1, minus here 1 upon x minus 3 into derivative of x minus 3, which is 1, minus 1 upon x minus 4 into derivative of this, which is 1, minus 1 upon x minus 5 here into derivative of x minus 5, which is 1. I'll repeat this. Derivative of log y is 1 upon y into dy by dx. Imagine these are the x, so 1 upon x minus 1, derivative 1, everywhere same procedure. Now finally, therefore dy by dx equals to y into here 1 upon x plus x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5. And you can put the value of y here, that is your answer. Right? No need to simplify further. If you want, you can take LCM on the bracket, but that's fine. This will do. Sorry, 1 by 2 I missed here. 1 by 2 is there. So 1 by 2 is there here. I'm sorry, that's there. You can put the value of y. So finally, dy by dx equals to, what was y? That is 1 by 2, I'll keep as it is. Root of this expression into this upon this into, inside the bracket, you just copy this expression over here. This is your answer, remember. This is your answer here finally. Okay, next question. Question number 3, third question. You have here log x raised to cos x. Now you see this question we cannot do without logarithmic function. Remember, one has to use the log function. So I'll use the log function here. There is no other way. So let's take this as a y here. Y equals to log x the whole raised to cos x. This is which form? Variable raised to variable form. So without logarithmic, this cannot be done, remember. So I'll apply log on both the sides. So log y equals to log of log x the whole raised to cosine x. Now this will be in the product, as you know. Which property? Again, just I'm reminding you, log of x raised to n equals to n log x. Okay. So therefore, log y equals to, this will be in the product, cos x into log of log x. So this is a simplified form. On the RHS we have used the property of the log function. Now differentiating with respect to x on both the sides. What is derivative of log y? Imagine this as x. What's the derivative of log x? 1 upon x. So 1 upon y into derivative of y with respect to x, that is dy by dx. On the RHS we use the product rule. Cosine x as it is. Differentiation of this. Imagine this as x. So 1 upon log x into, by chain rule, derivative of log x, which is 1 by x, plus log of log x as it is by product rule into derivative of cos. What's the derivative of cos? Minus sin x. I repeat this step. Cos x as it is by chain rule 1 upon log into derivative of log x 1 upon x, plus here this portion as it is derivative of cos, which is minus sin. So therefore dy by dx equals to y into, what about this, cos x upon log x into x minus sin x into log of log x. You can place the value of y. So finally dy by dx equals to, what was y? That is log x upon cos x into, just copy this expression. This is your answer. Now the same question can be done alternatively. So I'll do the same question. Now I'm doing the same question by some another way. There also logarithmic need to be used. You see, if you feel that this is easier, you can use it. Both are more or less same. Now, if you remember, one of the property of the log function, if you just recall, if you have e raised to log x to the base e, that is the power of exponential, base of exponential and base of log are equal, then the value is just x. So what I can do is, instead of x, I can write e raised to log of x. Instead of x, I can write e raised to log of that number. So I'm using the same concept here. Here, this is equals to, here, y equals to, what I'll do, you keep this as the x in your mind. So e raised to log of this given expression, which is log x the whole raised to cos x. I repeat, what I did, you imagine this as x, e raised to log of that x. Remember, here base is not written, means it is e. No need to write the base in the log function. If you are not mentioning the base of log function, if I write simply log, here it means it is log to the base e. Remember, so base is not important. If you are not mentioning base, that means base is e. Remember, e raised to log of given expression. That's what you have to keep in your mind. E raised to log of given expression. Now again, this power will be in the product. So y equals to e raised to cos x into log of log x. Fine. I hope up to this you are clear. Now you see RHS is in the form of e raised to x. This looks like x. What's the derivative of e raised to x? E raised to x. So now I'm differentiating. dy by dx equals to, imagine this as x. What's the derivative of e raised to x? E raised to x. Into d by dx of considered x. That is cos x into log of log x. I repeat this step. What I'll do, I'll imagine this as x. What's the derivative of e raised to x? That's the e raised to x into, by chain rule, d by dx of considered function. That is this. Okay. Now, if you just go back to reverse order, it is in turn log x the whole raised to cos x. From where you had this? From this one, so I copied that in short, because you are not going to differentiate this now. Differentiation of this. So use the product rule, cos x as it is. What is derivative of this? By chain rule, 1 upon log x into 1 by x. 1 upon log x into derivative of log x, which is 1 by x, plus log of log x as it is, into differentiation of which expression? Cos, which is minus sign. So finally, here we are getting dy by dx equals to log x the whole raised to cos x into, just you copy this expression, cos x upon x into log x plus minus minus log of log x into sin x. This is your answer. You are getting same answer. You see, just compare with the previous answer. Answer would be same. This was the answer. If you just compare this two, you are getting same answer. Log of this, cos of this one, here minus sine of this, right? So whether you do this way or this way, both are absolutely fine. Choice is yours, whichever way you like, remember. Important one is you must have variable raised to variable form, remember. Without, if you are not having variable raised to variable form, you can do without, log. Okay, let's go to next question. Question number 4. Fourth question. There the function is x raised to x, variable raised to variable. You must have realized 2 raised to sin x. This is not the variable raised to variable. Let us call this as fx, for example. Fx equals to x raised to x minus 2 raised to sin x. Now here you need to do either by applying log or as I explained here. I'll follow this technique. So fx equals to e raised to log of given expression, which is x raised to x, e raised to log of given expression. No need to do anything with this because this is exponential, This is not the variable raised to variable raised to variable, remember. This is a constant raised to variable. Derivative of this. This is like 2 raised to x. So we are doing nothing with this, remember. You cannot do derivative of x raised to x directly because it's a variable raised to variable form. That's why I've used this. Okay, now this x will come in product. So x into log x minus 2 raised to sin x. Up to this, it was just a simplification. Differentiation will come now in power, remember. Derivative will be now next step. So f dash x means differentiation. How will do this? Imagine this as x. What is derivative of e raised to x? E raised to x into d by dx of product of, that x log x, minus differentiation of 2 raised to x, 2 raised to sine x, into here log 2 into d by dx of sine x, which is cos x. Chain rule. Imagine this as x. What is derivative of 2 raised to x? 2 raised to x into log 2. And then by chain rule derivative of sine, what's that cos? Now final step, e raised to x log x. From where you had this? From x raised to x, remember. So instead of this, I'll just put x raised to x. What about this? Here I'll use the product rule. X as it is. What's the derivative of log x? 1 upon x. Plus log x as it is. What's the derivative of x? 1. Minus, I'm just copying this, 2 raised to sine x into cos x into log 2. And now finally last step, that is x raised to x into, this is 1 plus log x minus 2 raised to sine x into cos x into log 2. This is f dash x. You see here, differentiation of x raised to x is at the end x raised to x into 1 plus log x. I did the same question by applying log on both the sides. If you just go back to the first slide here, see this same question. But how I did here, applying log on both the sides. And how I did answer is same, x raised to x into 1 plus log a. In fact, you should remember in MCQs this might be useful. What's the derivative of x raised to x? X raised to x 1 plus log x. What's the derivative of x raised to x? X raised to x 1 plus log x. Here by applying log on both the sides, here what I did, I've used that e raised to concept, this one. Let me write your reason. Instead of x, you can write e raised to log x to the base e. Base you can drop. Right? That's what I did. Fine. Next question, question number 5. Your product of 3 functions. You can do by product rule also, but we apply log function on both the sides. So applying log y equals to, this product become addition, you know, log of x plus 3 the whole square plus log of x plus 4 the whole cube plus log of x plus 5 the whole raised to 4. Then what's the next step? You take this one in product. This will come in product. So next step is, therefore log y equals to 2 into log of x plus 3 plus 3 into log of x plus 4 plus 4 into log of x plus 5. Which property? You know here property is this, log of x raised to n, that is equals to n log x. This is what you did. And here which property? That into become addition. That's also one of the important property of log. Okay, now differentiation. So this you will try, differentiating with respect to x. I'll not do further. Try yourself. Chain rule. This you know, 1 upon y dy by dx. I'll go to next question. Question number 6, which is an important example. Let us take y equals to x plus 1 upon x the whole raised to x and x raised to 1 plus 1 upon x. You must have realized here both the functions, these and these, are in variable raised to variable form. So we need to use logarithmic. Without log this cannot be done. But directly you cannot apply log function c. This is not the property of log function. There are 2 functions. If I have x plus, for example, y, then this is not equals to log x plus log y. This is not true, remember. If you have addition, between the terms, you cannot apply the log function, remember, directly. If you have multiplication, you can apply the log function. That's the difference, be careful. So if I write directly log on both the sides, it's wrong. So what I'll do, I'll take separately this as u. So let's write y equals to u plus v, and I'll call this as 1. Where what is u here? U is the first function. That is the x plus 1 upon x the whole raised to x. And now I'll apply log on both the sides. So log u equals to log of x plus 1 upon x the whole raised to x. You must have realized what I did. I have chosen one function separately and applying log, because this is a variable raised to variable form. Now differentiation. Tell me what is derivative of log u. Imagine this as x. What's the derivative of log x? 1 upon x. So 1 upon u into derivative of u with respect to x, that is du by dx, equals to, sorry, I forgot to write one more step. You can take x in the product. So next step is x into log of x plus 1 upon x. This is the next step. Now I'll do the differentiation of this. Product rule, x as it is. What's the derivative of log of something? 1 upon something into differentiation of this by chain rule. So d by dx of x plus 1 upon x plus now this portion as it is, log of x plus 1 upon x as it is, into differentiation of x. What's the differentiation of x? Which is 1. I repeat, x as it is. What's the derivative of log of something? 1 upon something into d by dx of x plus 1 upon x, chain rule. Now this is as it is, derivative of x is 1. Therefore, du by dx equals to, u will go this side. Okay, so u will go that side. Here, if I take LCM, this x will be in the numerator, so x square, and this is x square plus 1 after taking LCM. What is differentiation here? Derivative of x is 1. What's the derivative of 1 upon x? Minus 1 by x square plus log of x plus 1 upon x as it is, right, into 1. This is as it is. So finally, du by dx equals to u. What was u? That is this, x plus 1 upon x the whole raised to x into, here if I take LCM, that x square minus 1 and that x square will get cancelled. So finally we'll get the x square minus 1 upon x square plus 1 plus log of x plus 1 upon x. I'll call this as, for example, 2. This is equation number 2. 1 is here. So I hope this is clear to you. This is very important part. What I did, I have taken separately, one as u, the other one as v. Then I've started with u, variable raised to variable form, applying log, and then differentiated. Now I'll go to next v. What is v? That is this portion, and then I'll follow the same procedure for v. Okay, so here, and v equals to, what is v? X raised to 1 plus 1 upon x, variable raised to variable form. Okay, applying log on both the sides now. So log v equals to log of x raised to 1 plus 1 upon x, and this will come in product. So log v equals to 1 plus 1 upon x into log x. This will come in product and log x as it is. Now differentiating with respect to x. What is derivative of log v? Imagine this is x. So 1 upon v into derivative of v with respect to x, that is dv by dx. 1 plus 1 upon x as it is into derivative of log x, 1 upon x, plus log x as it is. Differentiation of this by product rule. 1 derivative of 1 0 and derivative of 1 upon x is minus 1 by x square. Log v, 1 upon v dv by dx. Here product rule, this portion as it is. What's the derivative of log x? 1 upon x plus log x as it is, derivative of 1 0, 1 upon x minus 1 by x square. So finally dv by dx equals to, v will move this side. But what is v? That is, v will go this side. But what is v? That is x raised to 1 plus 1 upon x. Inside the bracket, if I take LCM, this is x plus 1 upon x squared, because one more x is there, minus this is log x upon x squared. This is nothing but equation number, I'll call 3. Now from 1, dy by dx equals to du by dx plus dv by dx, differentiating with respect to x from 1. 1 was this. What was 1? Y equals to u plus v. Okay, and then now placing the value. So finally dy by dx equals to, what is the value of du by dx from 2? That is that expression, x plus 1 upon x the whole raised to x into x square minus 1 upon x square plus 1 plus log of x plus 1 upon x plus dv by dx. What is dv by dx? dv by dx is here, x raised to 1 plus 1 upon x into x plus 1 upon x square minus log x upon x square. This is your final answer. From where we could write this? You can write from 2 and 3, from these two equations. From which two equations? From 2 and 3 we could get this final, placing the value of du by dx and dv by dx. This is one way of doing this question. Alternatively, even you can do, so I'm showing how to do alternatively, just one step I'll show you. Or you can do the same question by this way. So here question is y equals to x plus 1 upon x the whole raised to x plus x raised to 1 plus 1 upon x. Now what I'll do, I'll express these and this both in form of e. So y equals to e raised to log this expression, x plus 1 upon x, and this x I'll take directly here in the product, plus come to this e raised to log of given expression, that is x raised to this, and that power again I'll take in the product. And now differentiate. So dy by dx equals to, imagine this as x. So derivative of e raised to x is e raised to x, d by dx of this x, plus here derivative of e raised to x is e raised to x into d by dx of that x, and then continue. This is another way, I'm just showing you. This is little bit shorter, remember. Which property I've used here? X equals to, you can write log e raised to log x, that you have used. And then straightforward by chain rule. This is little bit shorter if you like this. Otherwise that method is also there. Choice is yours, as I mentioned. Question number 7 here. Log x raised to x, x raised to log x. Both are in the variable raised to variable form. So we need to use log. So let's use y equals to, I'll call this as y, log x the whole raised to x plus x raised to log x. Now there are two ways. You can call this as u, this as v, and as I explained. Or you can use that e concept. So I'll use that e concept here. Y equals to e raised to log of given expression, that is log x the whole raised to x, plus e raised to log of given expression, that is x raised to log x. Which concept you have used? X equals to e raised to log of given x. That's what you have used. X equals to e raised to log of x. Okay. Now you see both are in which form? E raised to, before that I'm sorry. I need to take this one in product. I need to take this one in product. So therefore y equals to e raised to x into log of log x plus e raised to, this will come in product, log x into log x. This log will come in product and log x here, remember. Now differentiation, because this is e raised to x, this is e raised to x, so straightforward dy by dx. So dy by dx equals to, what is derivative of e raised to x? E raised to x. So e raised to x into log of log x into, by chain rule, d by dx of x log of log x plus here derivative of e raised to x. So e raised to x here log x, this is log x whole square, so I'll write this one as it is, into d by dx of which one? Log x the whole square. What you did here? Chain rule, nothing more than that. Imagine this as x. What's the derivative of e raised to x? E raised to x, derivative of x, plus this is log x into log x means log x the whole square. Imagine this as x, d by dx of this one, which is this. So finally dy by dx equals to, now reverse procedure, from where you had this expression, from this, that is this. So instead of this you need to write the original expression, which is log x the whole raised to x. Here product rule, x as it is, here 1 upon log x into derivative of, by chain rule, log x, which is x, plus log of log x as it is, what's the derivative of x, which is 1 over here, plus now from where you had this expression, from this, that is original expression is this, so I'm just copying, that is x raised to log x into, now here chain rule, so this is like x, what's the derivative of x squared? 2x, so 2 log x and derivative of log x, which is 1 by x. So finally dy by dx equals to log x the whole raised to x into, this x will goes away, 1 upon log x plus this is log of log x plus your x raised to log x as it is into 2 log x by x. So you can write minus 1 power if you want. Actually you can write like this also, x raised to log x minus 1 if you want here, but this is your answer finally. The next question, 8th question. You have here sin x raised to x plus sin inverse root x. Now this is variable raised to variable, but this is not the variable raised to variable. This you can do directly by chain rule. So here you need to use that e concept. So y equals to e raised to log of sin x, the whole raised to x, and that x I'll take in the product. This one as it is, remember. Which concept have used? Again I'm emphasizing x equals to e raised to log x. That is what you have used. Only in first step, remember. Only in first step. This is as it is. Because this is a variable raised to variable. Now differentiation. So dy by dx equals to, what is derivative of e raised to x? E raised to x. Into d by dx of here x into log of sin x. Plus, how we'll do this? This is directly by chain rule. Imagine these are the x. What is derivative of sin inverse x? 1 upon root of 1 minus, this is x for us, root x the whole square into d by dx of root x. Imagine these are the x. Derivative of e raised to x is e raised to x, d by dx of that considered function. This one, you are directly chain rule. What's the derivative of sin inverse x? 1 upon root of 1 minus x means root x the whole square into this. Now final step, from where you had this from the given expression. So here sin x raised to x. What about this product rule? X as it is. What's the derivative of this? 1 upon sine into derivative of sine, which is cos x, plus here log of sin x as it is into differentiation of x, which is 1, product rule inside the bracket, plus this is 1 upon root of 1 minus x, square root and square will get cancelled. What's the derivative of root x? 1 upon 2 root x. Okay. So now, therefore, finally sin x raised to x into here x into cos by sin is cot x plus log of sin x plus here 1 upon 2. You can merge these two roots, so x and x, so x minus x square. This is your final answer here.